Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That special channel created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Thanks for staying tuned, because without you, we will be here on Mathematics by Abu Zainab. Today, we are continuing on our lesson on the topic sequence and series. We had our first video on this topic in the last posted video, which I enjoin you to please revisit for a proper introduction. In that video, we did explain the concept or difference between sequence and series. And in summary, sequence basically is a set of numbers of values that follow a particular or regular or constant pattern through which we can predict subsequent terms. And we did say that series, on the other hand, is simply the summation, that is, the addition, subtraction, or a mixture of both operations of the terms of a sequence. Hence, these terms are interchangeably used at times, but that is basically the difference. Why one is summation, the other is not summation. And then we looked at a basic example of what a computation in sequence is all about. We are taking this topic a notch higher today by going deeper. Of course, not to forget that in that last video, I did mention that we have quite a numerous examples of sequences. We have alternating, we have P series, we have negative series, Taylor series, Fibonacci sequence, and so on and so forth. But I emphasize then that for the ordinary level examination, we are basically focusing on the arithmetic progression, popularly called AP, and geometric progression, popularly called GP. So for this lesson, essentially, we are looking at the arithmetic progression, AP, also called linear sequence. So what is the AP? To start with, we need to understand the concept of the nth term of an AP. As we have on the board, we have this formula for deriving the nth term of an AP. It's given as UN equals A plus N minus 1D. With illustrations, I'm going to explain what each of these parameters in this equation stand for. Let's say we have 6, 4, 2, and 0 on one hand. Then here we have 3, 7, 11, 15 on the other hand. So using these two illustrations, I've explained the concept of each of these parameters in the equations. What is A here and what is A here? A stands for the first term. A is the first term, meaning in order, the very first term here is 6. Similarly, the first term here is 3. That sorts out A. A stands for the first term. N stands for the number of terms in each sequence. So for this particular example one here, we have how many terms here? 1, 2, 3, 4. Definite. So we have N being 4. Whereas here, N is not necessarily 4. We only have the first, second, third, fourth. There are still more terms that are not indicated. So we can't say definitely the number of terms here because we don't know how many terms follow 15. So here we're going to have a question mark. We don't know for certain what N is. So N basically means the number of terms in each sequence. D is very important to emphasize here that oftentimes candidates make a lot of mistakes when it comes to how to obtain D. D stands for common difference, the difference that is common between the successive terms. So for emphasis, to obtain a common difference in an AP, we use the formula U2 minus U1, meaning the second term minus first term. Or we say the third term minus second term, on and on and on. We can also say the fourth term minus third term. So if in the successive subtractions we get the same answer, we call that common difference, and that establishes that the sequence is an AP. So if you look at this, 4 minus 6 is minus 2. 2 minus 4 is also minus 2. Likewise, 0 minus 2 is still minus 2. We can conclude that the common difference is minus 2. Again, emphasis is the second minus first, the third minus second, the fourth minus third. Not the first minus second, second minus third. Not that way. If you try to work in that way, you certainly are going to get the wrong value for E, and which consequentially is going to affect the entire workings. Now, coming here, our common difference is similarly 7 minus 3, which is 4, 11 minus 7, also 4, and 15 minus 11, also 4. So we have 4 there. It's very important we get that correct. As a matter of fact, when you have a sequence in an exam without being told, a quick way to know, to determine what type of sequence it is to try the subtraction method. If you try subtracting accordingly and you have a constant answer or true, which is called the common difference, then that establishes that that sequence is an arithmetic progression, or AP. So then we have looked at A, N, and B. Last thing is the UN. UN basically stands for the last term or the end term. So in the fourth example here, the obvious last term here is 0. So UN is 0 here. Whereas in this case, we don't have any definitive last term because it continues on and on and on. So that last term is basically unknown. So this is basically an explanation of the various terms indicated in the formula for n term of an AP. And this paves the way for us to go into examples proper. So we take our first example here. So we are required to find the 12th term, then the nth term, and lastly the 3n plus 4th term of the sequence. Recall, it's not every time you'll be told what the sequence is, so you need to detect by yourself. The sequence is given as 2, 9, 16, and so on and so forth. So if you are given this in an exam, before you jump into using any formula whatsoever, you have to first identify what sequence this is. So mentally, let's try the subtraction method by saying the second minus the first and 10 minus second. So we go 9 minus 2 is 7, 16 minus 9 is also 7. Automatically, that tells us it's an AP because we have a common difference. Then we are safe to use the formula for the n term of an AP, which is n equals A plus n minus 1 D. So listen parameters here, we have A, which is first term, 2, D, the common difference is 7. How? 9 minus 2, and then 16 minus 9. So for question 1, we have to find the 12th term. So basically what that means is anywhere I have n, I substitute 12. That's meaning. So for 12th term, I have U12 equals A plus 12 minus 1D. Replacing n with 12. Hence we have A plus 11D. That's the 12th term. So substituting the values of A and D, we're going to have 2 plus 11 times 7, which is 2 plus 77. And the 12th term is going to be 79 for that particular first question. Then we have the nth term. We are required to find the nth term. So as I said, the n simply replaces the n in the formula. Just the way 12 replaces n. So the n remains n here. We just substitute our A, which is 2, n remains n, and D, which is 7. So in simplifying, we have 2 plus 7n minus 7. And collecting like terms there, 2 minus 7, we have minus 5 plus 7n. That is the nth term. And lastly, what's the 3n plus 4th term? So in this case, 3n plus 4 in its entirety replaces the n in the formula. So I'm going to have U 3n plus 4. So anywhere I see n, I'm going to substitute 3n plus 4. then minus 1 in the formula. Look at that. 3n plus 4, that is value of n, then minus 1. So A is 2, so we have 3n, 4 minus 1 is plus 3, and D is 7. So we have 2 plus 21n plus 21. And collecting like terms, 2 plus 21 equals 23 plus 21n, and that is the 3n plus 4, 10, which I believe is quite an interesting way to start. So basically, what you have there is using the formula for the nth term of an AP. So let's take one more question to see how this formula is applied. Here we are required to determine how many terms are there in the sequence. Again, we are not told what sequence it is, so that's left for us to find out. 24, 21, 18, then the last one is minus 72. So how many terms are there in this? Again, let's find out what type of sequence this is. 21 minus 24 is minus 3. 18 minus 21 is also minus 3. So that establishes that we are dealing with an AP here. And you can simply use the formula. But before then, let's list the parameters. A is the first term here, and that's 24. D has been confirmed to be minus 3. N, which is what we are asked to find out how many terms are there. But we have our last term there, UN, is minus 72. Because UN doubles as the last term, just as it is the nth term. So after doing this, it's just a matter of substitution in the formula for the nth term. So UN is minus 72, A is 24, and D is minus 3. So simplifying this simple equation, we have 24 minus 3n plus 3. So minus 72 equals 24 plus 3 is 27 minus 3n. So when we simplify from that, we have plus 3n equals 27, of course, plus 72. So 3n equals to 99. Therefore, n is equals to 33. So in conclusion, there are basically 33 terms in totality in this sequence, starting from 24 and terminating at minus 72. So these are some of the basic applications of the formula, the nth term for an AP, which I believe you found quite interesting. In order to bug you much with so much in this video, I will break this into another video where we take further, more technical, yet interesting examples that has to do with nth term of an AP. If you love this video, please don't forget to subscribe, like, share, and ultimately turn on your button so that you'll be the first to know when our next video is dropped. And that's going to be the continuation of the application of the formula for the nth term of an AP. Stay tuned and stay blessed. Thank you.